And 17, differential part B. This only goes for 20 marks. You can see the marking scheme or the solutions just in the corner, and we'll see what we're looking at here. Spacecraft of center of mass M moves in a straight line towards O. It's going towards it.
So it's frozen.
Okay? And towards O, the center of the Earth's of radius big R. When P is a distance x from O, the force exerted by the Earth on P is directed towards O and has a magnitude of k over x squared, where k is a constant. Show that k equals mgr squared. Okie dokes. mg weight equals kr squared. Okay. Spacecraft of mass m moves in a straight line. Alright. I think it's like Newton's gravitation. You would have done, some of you would have done this in physics, okay? Do you know when you're lying on the surface of a planet, what happens? Huh? Your weight mg, because we're on Earth, aren't we? So your weight, it's not any other planet, it's Earth. So when you're on the surface, your weight is mg going directly down, and what's attracting you towards the Earth? What? And how far are you away from the Earth when you're on the Earth? R. So mg equals k over r squared. What then? K equals mg r squared. Done. Is that alright? Because when you're on the surface of the Earth, it's your weight acting downwards has to be equal to the attractive force that causes you to go downwards, or they're equal to each other. Okay, P starts from rest when its distance from O is 5r. So that means 4r above the Earth. Would that make sense? 4r above the Earth. No bother. Find in terms of r the speed of P as it hits the surface of the Earth, given that air resistance can be ignored. Okay, going to get rid of all this other stuff here. Let's see what I can make sense of here. So F equals, okay, there's two ways of doing this, alright? See later in the solution it has a distance of 5r. It's taking 5r as positive. Okay? So from here to here is 5r. What they decided to do is decided to make the force negative. Because 5r from here to here is a positive 5r, so in the opposite direction is considered negative. Does that make sense? Okay, we might do a side by side. We might do what happens if you use the wrong sign. That makes sense? And we'll have a look at what happens if you use the wrong sign at the start of the question. So F equals minus k over x squared. Happy enough with that? Which in turn equals what? What's k? mg r squared over x squared. Okay. What type of question is it? It gives us that v equals 0 when t equals 0, when x equals what? X equals 5r. No bother. And then it's v equals whatever v. We're looking for v, aren't we? When x equals r, not 0. Was it not 0? It hits it there, doesn't it? Okay. So what are our choices? Remember, it's MA, and MA can be either what's it, dV dt, or it can be mv dV dx. Which one should I use on y? Y. It's velocity related to distance, and we're looking for the velocity in this question. Okay. It's not. We have the limits for distance, not the limits for time. You see the way we have both distance limits, but we only have one time limit. Okay, that's why we have to choose the second option over the first one, because we just have two sets of letters here. Well, we have actual numbers for that. Okay, so minus mv the v dx, which is force, equals negative mg r squared x squared. Everybody cool with that? Then what? Cancel the ends, no bother. Then what?
Bring up to the x, g or sorry.
Yeah. So would everybody agree that gr squared is a constant? So minus gr squared is a constant, no bother there. And then it's 1 over x squared dx, and then on this side it's just v to v. Now what can we do then? What limits? So 0 and 5r are matched up, and r and v are matched up. Yes, sir?
If you put 0 on top and v on bottom, and then 5r on top and the r on the bottom, would it make a difference?
It does, yeah. It's opposite in sign. Do you want me to check that out for you in a second?
Yeah.
Okay, so the problem is, Owen, is that at velocity equals 0, you're 5r away from the center of mass. Well, if you said, if you switch that around, you'd be saying that you're going to, you say you'd be stationary when you're on the planet's surface as opposed to crashing into it. So switching those limits is fundamentally wrong. Unless you switch both limits at the same time. Are you talking about 0 to v?
Well, like if
Are you talking about putting 0 here, that, and then putting 5r up here and r down here?
Yeah.
That works perfectly, because they're still in sync with each other. That'll work perfectly. Everybody right with that? Now, phi squared over 2 from phi to 0, and then what? 1 over x, isn't it? Oh, sorry, yeah. I'll do the in-between step. Take away 1, isn't it? Or add on 1? Add on 1? Okay. And then, well, I might as well just 1 sec there. Now, actually, you close that. Is it still open? Alright, sorry. Now, from r to 5r. Is that okay? Now, here's what we're going to do next. Phi squared over 2. And then, what's this? That's basically minus 1 over x, isn't it? That whole thing. So it's minus 1 over r, and then plus 1 over 5r. Common denominator?
Then you have the gr squared.
Oh, and the minus gr squared on top, yeah? What happens then, guys? And the minus g r squared on top. The r's, well, one of the r's will cancel, won't it? Okay. That's minus 5. Minus 5 plus 1, isn't it? So it'll be minus 4 over 5 minus gr equals phi squared over 2. So what we're looking at, 4gr over 5, phi squared over 2, 8gr over 5 equals phi squared. Phi equals the square root of 8gr over 5. Alright, what on God's green earth am I doing again? Alright, Grant. Let's see if I'm right. Yeah, 20 marks. Done and dusted. Let me save it. Owen.